All right, hello everyone. So today we have a trigonometry problem. So given tangent of theta equals minus 4/11, theta is in quadrant 4, find the following trig function. So we're looking for A, sine 2 theta, B, cosine 2 theta, and C, tangent 2 theta. And all of these involve double angle identities. And right, we have several double angle identities. For sine of 2 theta equals 2 sine theta cosine theta. Cosine 2 theta, there's three versions of it. 2 cosine squared minus 1, 1 minus 2 sine squared, or cosine squared minus sine squared. So typically figuring out the cosine double angle is a little more complicated because it depends on the information that's given. For sine, for that double angle formula, that's a little easier because you know exactly what you need to find a sine and a cosine. All right, and then finally we have the tangent of 2 theta equals 2 tan theta over quantity 1 minus tangent squared theta. So when we're looking at these types of problems, the first thing I'd suggest we do is to look at the information and maybe perhaps make a drawing. Tangent of theta is minus 4/11, and theta is in quadrant 4 here. Now, that if I drew that angle out, you would have a picture as such. And right, if you recall, tangent is y over x, so y would be -4 or any multiple of -4, and x would be 11 as shown right here. And recall also that cosine theta is x over r and sine of theta is y over r. So the only issue is I don't have r. R is the distance from this point right here. It's like, yeah, the point where the angle terminates, all the way to the origin. That's what r represents. And we know we're given that r squared equals x squared plus y squared. So we can figure r out, yeah, because we're going to need that eventually. We need to find out what sine and cosine are for us to solve for the identities here. So 11 squared plus minus 4 squared, 121 plus 16 is 137. So r equals the square root of 137. Okay. All right. So with that being said, we can find out what sine and cosine are, and then we can work with our double angle identities with our formulas. So let me just move this over here. There's a little bit of space. So sine of theta, and in fact, let me replace the r here with the square root of 137. So we would have that sine of theta is y over r. So y over r would be -4 over the square root of 137. Okay. And cosine of theta is equal to 11 x over r, so 11 over the square root of 137. And if I'm looking for a, which was sine 2 theta, all you do is replace sine theta and cosine theta with what they are. So sine theta is -4 over the square root of 137 times cosine, which is 11 over the square root of 137. And if you multiply all that together, you get -88 over this 137. The square roots cancel. Okay, so that would be my value for sine 2 theta. So for cosine 2 theta, you have three versions that you could use, as I said. I'll let you rewind back so you can see which one version they are. I'm going to use this version right here because I know what cosine theta is. I could have also used 1 minus 2 sine squared because I know what sine, and in fact I could have used cosine squared minus sine squared. That's the third option here for cosine 2 theta, but I'm going to just use that one because I don't know, it's just more direct in my opinion. So cosine of theta is 11 over the square root of 137, but we need to square that. That's what that 2 means, middle, so -1. So then you're going to get 2 times 121 over 137 minus 1. 2 times 121 over 137, you get 242 over 137 minus 1. So if you get a common denominator of 137, let's see here, looks like you get 105, if I'm not mistaken. 7, 5, 12, 1, yep. So 105 over 37 is your value of cosine 2 theta. And last but not least, tangent of 2 theta. Now, I'm going to use the identity 2 tan theta, 1 minus tangent squared theta. But since you know what sine 2 theta is and cosine 2 theta, you can plug those in, because you know cosine 2 theta and sine 2 theta, you can figure out tan 2 theta from that. You don't need the identity because tangent is sine over cosine. But here I'm going to plug in that just to show you how that identity works here. So 2 times minus 4/11 over 1 minus negative 4/11 squared. So you would get negative 8/11 all over 1 minus 16 over 121. And you get negative 8/11 divided by 121 over 121. And yeah, you would get 121 minus 16, which would be 105. Yeah. So you get negative 8/11 times, so I'm going to flip this fraction around, 121 over 105. So this goes in 11 times, and you would get negative 88 over 105 for your tangent of 2 theta using the identity. Okay. All right. I often get questions. Let me go back to the triangle that I drew. When I get the values for sine theta and cosine theta or whatever else I need to find, is there any other way of doing this without a triangle? You could use the Pythagorean identities, like for those that don't recall what the Pythagorean identities are. Pythagorean identities are the ones that have cosine squared plus sine squared equal to 1. So let's write these down here. Secant squared equals 1 plus tangent squared. Then finally cosecant squared theta equals 1 plus cotangent squared. Those are the Pythagorean identities. So you could use those as well. However, I find this to be a bit of a longer process, computationally speaking, but you can use those. Okay. All right. Well, thank you very much for your time, and I hope this helps.